Look at these awesome trains. The animations are so amazing. I wonder how they were made.
These were created by combining MTR mod with JavaScript.
MTR, Minecraft Transit Railway mod. I know, it's for train simulation. But what's JavaScript doing here?
JavaScript is a programming language. In the case of MTR mod vehicles, JavaScript can be used to render things on them.
Rendering? How does it work?
Basically, MTR mod vehicles are rigid models which can only move along dedicated tracks. They can be animated, but only in very few cases, such as opening and closing doors, as well as on the default monochrome screen. But with JavaScript, you can create a lot more animated effects, like screens with more details. Moreover, if your vehicle model is in OBJ format, you will have direct control over your model's every single part.
Sounds cool. That's why some MTR resource pack creators want to dive deep into JavaScript. But not the case for me. I'm not that good at coding.
No worries. I'll guide you on creating your first JavaScript project.
Really?
Let me tell you what to install. Important, if you only install MTR mod, your JavaScript code will not work. You'll need extra mods.
What else do I need?
It depends on the version of MTR mod you're using. If you're using MTR 3, you'll need to install NTE, Nemo's Transit Expansion mod. If you're using MTR 4, you'll need JCM, Jobin Client mod, version 2 or higher. Do check for the mod's documentations, since these prerequisites might change.
All done. I just created a new world. You mentioned that I need to code? Is it inside the chat, on the sign, or…
No. You're not going to write that code inside the game world. You need to edit the code inside a resource pack.
Resource pack? Do I have to make it from scratch?
Literally, yes. But for this tutorial, I've already prepared a template for you. Just download it and enjoy.
That's great. I'll download it right away.
I've uploaded the template pack to Modrinth. Go to Modrinth's resource pack tag and search mtrain with InfoPanels. Enter the description page and click the versions tag. Select a pack that matches with your MTR mod version. Note that for each pack, you can download the complete code to play around, or download the DIY version to follow this tutorial. After downloading, you'll get a zip file. To make coding easy, you'll need to extract the zip into a folder and move the original zip file to somewhere else for backup. We're going to use a train named mtrain normal with InfoPanels.
Looks identical to the default mtrain from MTR mod. What are we going to do with JavaScript?
Go inside the train. Near the driver's cabin, on the left side of the train, look up above the large window. You'll see a screen.
Anything special about it?
It's called InfoPanels, an LED dot matrix screen that has been used in Hong Kong MTR for decades. In reality, it can show time, next station, and even news and advertisements.
Sounds good. But why is there only one screen inside this carriage?
Good question. From now on, you'll need to really start coding. The position of every screen is controlled by code. Open the resource pack folder that I shared with you. Look for main.js. It contains the code for the screen's position. By the way, you can use any text editor to edit your code, but I'll recommend dedicated coding software, like Visual Studio's Code. I've added annotations. The code for the screen's position is here.
So many numbers. Do they mean anything?
Let's first focus on the part labeled offsets. This part controls the transform distance of the screen, meaning how far you want to move your screen. There are 3 values here, enclosed by a pair of square brackets. In JavaScript, things like multiple values separated by commas and enclosed by a pair of square brackets are called arrays. For this array, here's the logic. For the first value, increasing it makes your screen go left. For the second value, increasing it makes your screen go up. For the third value, increasing it makes your screen go forward. Do note that these values may not be the same as the X, Y, and Z coordinate values of the game world. Don't mess them up.
I see. What if I want to copy the screen?
To copy the screen, you'll need to copy the array. You see, in each carriage, there are 4 big windows on one side, so we'll need a total of 4 arrays. The first array represents the original position, so just keep it unchanged. Now, think about how to change the values for the other arrays.
Let me see. These 4 screens share the same distance from the left side. They also share the same distance from the upper side. The only difference is their distance from the front side. Therefore, for each array, the third value needs to be changed. In this case, since the distance between every two screens is 5, so the third value in each array needs to be 5 less than the value in the previous array.
That's right.
Okay, now we have a screen on every window on the left side. What about the right side?
Now we'll focus on another part of code. Since the screen on two sides have different facing, they need to be flipped. Offsets only controls their transform distance. If we want to flip, rotate, or stretch the screen, we need to modify the pose section.
There are 4 arrays. What are they used for?
Good question. You see, each screen is a rectangle, and the 4 arrays represent the positions of the 4 vertices. To be more specific, Array 1 controls the upper left vertex, Array 2 controls bottom left, Array 3 controls bottom right, Array 4 controls upper right.
Upper left, bottom right, upper right.
Then, since there are currently no screens on the right side, we need to copy the screen from the left side.
Just copied. What about the 3 values in each array? Do they share the same logic as in offsets?
Exactly, but this time, we're controlling the position of every vertex. Now, try and see how to move the vertices in order to flip the screen.
Let me see. Array 1 controls the upper left corner. Inside it, increasing the first value makes the vertex go left.
This part needs to be tried slowly. For now, I'll just share the answers.
All done. It looks nice. What are we going to learn next?
JavaScript is very powerful, and there are a lot more to explore. But for now, let's take a break.
Okay, see you.